Hi, students. We're back with the last and final component of lesson 5.1. So this is 5.1 part 5, and we're going to be looking at how do you solve on the interval of 0 to 2 pi using the unit circle. So as we look at this next unit of study, this next section of study, remember that all your values that you get out for answers should be able to be found utilizing the unit circle. If you need to pull out your copy of the unit circle, it would be really helpful as a reference, but we're hoping that you'll really start to get more familiar, comfortable, and confident with working with that unit circle values. So let's go ahead and jump in. Today I have 3 examples for you, and we are going to still be utilizing the identities and the learning we did earlier in 5.1. We're just going to utilize that and connect it to the unit circle. So in this particular problem, we are given this solving, and whenever you're solving, I really encourage you get it set equal to 0 because it means that you're going to be able to use the zero product property from quadratics, which just says when you have 2 terms multiplying together and they equal 0, you can set each term equal to 0 and finish solving. So as I look at this problem, I see that I have 2 terms, and these 2 terms both have cosine in common. So I'm going to go ahead and factor out the cosine, and that leaves me with 2 sine of x minus 1 equals 0. Now that I've factored this into a product of 2 terms and it is equal to 0, I ask myself, when does cosine of x equal 0? And when does 2 sine of x minus 1 equal 0? Well, I can go ahead and solve this right now using the unit circle. If I'm looking at the unit circle, I'm looking for when is the cosine value or the x coordinate 0. Well, the x-coordinate is 0 at pi over 2, and the x-coordinate is 0 at 3 pi over 2. So I'm going to for sure have to include those in my answer. But I also need to look at how do I solve this. So in solving for sine of x, I would add 1, and then I would divide by 2, and I get 1/2. So now I'm going to look at my unit circle and say, okay, well, when do I get 1/2 for my sine coordinate? Well, 1/2 sine coordinate is the second coordinate. So I'm going to have 1/2 happening at both of those values. All right, so we can now take and combine. Again, I'm just going to take a second and highlight the green was from the cosine solving one, and the blue highlighted part was from the sine. And now I can write my final answer. X is going to equal all 4 of those highlighted radian measurements. So we have pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. We just successfully factored and solved for x using our unit circle. All right, let's take a look. I have 2 more examples for us to try today. Our next example is here. In this example, it's asking us to find all solutions again on the unit circle. So eventually we'll go back to using the unit circle. And so I see tangent squared and I go, okay, setting equal to 0, not really helpful. I already have a value by itself. So I'm going to get tangent by itself. So I take the square root of both sides and I get tangent of x equals plus or minus the square root of 3. Don't forget about that plus or minus. It's very important. Now, this particular situation, though, is going to cause us to have to think a little bit more about the unit circle and about that tangent idea. So recall that tangent is equal to sine divided by cosine. So on the unit circle, this means taking the x coordinate divided by the y coordinate. So I usually tell students, figure out, because it's a root 3, I know that it has to be either at my pi over 6 or pi over 3 measurements. So I usually tell my students, just pick one, divide it. If it doesn't equal it, the other one should. So let's start with the pi over 6. And if I wanted to find tangent of pi over 6, I would take 1/2 divided by root 3 divided by 2. And when you are dividing by a fraction, you multiply by its reciprocal. That makes the denominator now no longer part of it. I can reduce the 2's and I get 1 over root 3, which, is this going to simplify to the square root of 3? Unfortunately not. It simplifies to root 3 over 3. So this is not going to be the value we want to work with. Let's test out the other one. So let's test out tangent of pi over 3. Well, tangent of pi over 3 would be root 3 over 2 divided by 1/2. Again, multiplying by the reciprocal gives us root 3 out. That's perfect. That's what we were hoping to have happen. So we know that at the top values, we are going to end up, so at this value, we'll end up with positive root 3. Because these points reflect, we also know that at all of the thirds are going to produce this. So I'm going to have to include all of these values because we said it was plus or minus root 3. So going back and writing or stating my final answer, I would say x equals pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. Fantastic. All right, I have one more example for us today. And here you have it. So in example 15, the final example for this section, we are given this problem, and we want to find all solutions from 0 to 2 pi. Well, this is a quadratic. It's all in terms of sign, which is great. It means we can jump right into asking our magic questions: what adds to equal 3, the middle number, and multiplies to equal 2, which is the product of the first and the last term. When I think about my factors that will make this true, I very quickly come up with, well, the only factors of 2 are 2 and 1, so it must be 2 and 1. Next, we are going to go ahead and factor this. So creating a box for us to do our factoring in. Remember that the first term goes in the top left box and the last term goes in the bottom right. And then the middle terms are the magic question numbers. And in this case, sine x is attached because that's the middle term. So we have 2 sine x and 1 sine x. Now we start to do our factoring. In this case, we would need to make sure this is a 2 sine of x because horizontally that's what they both have in common, which makes this sine of x along the top. What times 2 sine of x equals 2 sine of x? That's a 1. And what times sine of x equals 1 sine of x? That again is a 1. All right, so we've now factored it. So we have 2 sine x plus 1 times sine of x plus 1 equals 0. Now that we've factored it, we're ready to go into part 2 of this, which is setting each factor equal to 0 and solving. So product of 2 factors are set equal to 0. And we continue doing our solving. So the first one, 2 sine of x equals negative 1. Dividing by 2, when does sine of x equal negative 1/2? And then we also need to figure out when does sine of x equal negative 1. So I'm going to go ahead and grab my highlighter and help us navigate this. So let's start with this. We're looking for what is the radian measurement when we get negative 1/2 out as our second coordinate, so as our y coordinate. So that happens here at 7 pi over 6, as well as here at 11 pi over 6. And then we also care about when is sine of x, or what radian measurement do we get negative 1 out for the y value. And that happens at 3 pi over 2. Because we're only concerned about from 0 to 2 pi, we can now write our final answer as x equals 7 pi over 6, 3 pi over 2, and 11 pi over 6. There you have it, our final lesson on 5.1 involving our trig identities, factoring and solving on the unit circle, as well as simplifying using our trig identities. I hope you're starting to get the hang of this, and if you have any questions, just let me know. Have a great day.